Good morning, everyone, and welcome to the fourth episode of the Ben and Danny show. I was about to say it the other way around then. I'm so confused what we've called this show. So the last episode, we talked about... Oh, hold on. The YouTube channel just started playing. The last episode, we talked about placing sprites within the scene. We looked at why prefabs were so important. And then we created our first script, so we moved the diamond up and down. But Ben, what are we doing in today's episode?
So we, well, I hope we should be following on from last time. So, we made, last time it was kind of introducing you to scripting. This time we're going to go a bit into a bit more depth with scripting. But along the way, we're going to have a look at colliders. You've probably heard us talking quite a lot about collision detection. It's a big part of games development. But you've probably heard us talk about, colliders, collision detection. Today is the day we're going to have a look at that. So we're going to have a look at some colliders. We might touch on collision detection. I'm not sure. But, as you can probably tell, this is mostly unscripted, and we just kind of we just make it up as we go along, right?
We go with the flow, basically.
Yeah. So, that's one thing we should cover is colliders. Another big part of games is input. So things like, when you press a key, something happens. When you click a mouse button, something happens. Or, if you have a gamepad, something happens when you press a certain button. So we're going to have a look at that. We're also going to have a look at physics. So we're not going to go... I think usually when you say, we're going to have a look at physics, people go, oh, no, not physics.
Not Jesus. Physics.
Yeah,
it's like
no, and
last week with maths, I was like, no, not maths.
Yeah, people immediately start thinking of equations, and so we're not going to look at physics in that sense. We're going to have a look at how you can make an object react to things like gravity and move force-based stuff. We're going to have a look at that, and we're going to have a look at something called rigid bodies, and all of this is for creating a character that moves, right? So we're going to put a character into the game, and then we're just going to make that character kind of move around in the environment. So we're going to have a look at that. So we'll probably start off with making the character jump, and that involves physics and stuff. So we'll have a look at that. Colliders are another big part of this. So like I said, we're going to have a look at that as well. But it's worth noting, by the way. So we're going to get a character moving around the environment, but just to warn you, right? At the end of this, the character isn't going to have any animation. So the character is going to move around in the environment. But it might
they're just going to be kind of like static in a pose, practically.
Yeah, they'll be moving around the environment, but it won't look like they're walking. So that might sound like a bit strange, but
it might seem a bit backwards to try and get the movement before the animation, but it makes it easier to kind of look at and understand kind of the core coding and the core elements of it, to then you can polish it after you've got the core components.
So that's essentially what we're going to do. So it might look a bit odd, but that's okay. That's fine. We're just going to kind of focus today on actually getting the character moving around the environment. Then we're going to refine it in later episodes. So we're going to look at animation and stuff. Part of the reason we're doing this is, animation is a very big topic, and I don't think we could squeeze it in today. So
it's not like a 5-minute thing of you do this and this. It needs a focus on it. So you can understand it.
Yeah, but it shouldn't be too hard in later episodes. So, just a disclaimer: this isn't going to be the finished product. We're just going to have a look at the physical movement of the character in the environment. Hopefully that makes sense. So it's worth noting as well that we do this kind of stuff in industry. So if you work in a games development company, this process is
getting the like the simple practice of movement first, and then the polish of animation and making everything look kind of natural. Yeah, it is done in industry, so it's a good way to already learn how to do game design.
Yeah, exactly. I mean, I say it's used in industry. At least every games development job I've had, this is how it's kind of thing. And you'll find it not just for character movement, even something like making a menu, for example. You will have a menu that looks terrible, right? But it works, and then later on you'll add all the fancy effects and stuff, because that's
they're the fun kind of part as well.
Yeah.
I like adding all the After Effects.
Yeah, and I think oh, sorry, carry on.
No, I think you're going to say what I'm saying.
Yeah, but yeah, like polishing something and making it look good is what you spend the most time on. I think one of the things about polishing is there's no stopping point, right? So
like me, you can go a bit overboard on the polish and all the pretty things.
Yeah, I've spent hours, not even hours, days, like just making sure everything looks fine, and people have had to kind of come along and say, hey, actually just
chill.
calm down. I think it's already, but I'll give you an example. I mean, I know I'm going off tangent here, but whatever. So I was making a weather system for a game, and I spent like every tiny detail in making this weather system. I got the skybox rotating. I made it transition weathers, and it got to the point where my supervisor on that project was just like, calm down. I think it's done, Ben. Just relax. And I suppose that's also like a cautionary tale. If you're making this game, you might find that you spend so much time getting something looking good and polishing it and stuff. And yeah, it's sometimes you just lose track of what's important, what's not. So
get the basics down, get the actual functionality of the game working, and then you can go back to do the pretty stuff.
Yeah, exactly. So yeah, that's pretty much it. That's what we're going to cover today, and that's kind of how we're going to go about it. So I suppose the first thing we should look at are colliders. I mean, we mentioned colliders quite a lot, and I said, oh, collision detection. What's that thing? So we're gonna have a look at colliders, and I'll probably show you actually in the editor itself.
I'll put that up for you.
Yeah. So I'll show you colliders in a second, but I suppose one of the questions you might be thinking is, well, what is a collider?
What's a collider, Ben?
Yeah. So yeah, I would say it's probably best to describe what collision detection is. Collision detection is, I suppose, something that we kind of use in our everyday lives as humans, I would say. So we can do this quite naturally. We know when two objects are touching each other, right? Now, collision detection is exactly that. All it is detecting if two objects have touched each other, right, or are intersecting. That's really all collision detection is. There is other information in that. So where have they collided? Where have they collided? When have they collided? All this kind of stuff. Have they touched multiple points? All that kind of information as well. But largely, that's all collision detection is really. Is just detecting if object A is touching object B. And you might think, okay, well, that sounds interesting, but why is this important? It seems like such a weird idea. Well, we find it in games quite a lot for, I would say pretty much, not everything in games, but quite a lot of stuff in games involves collision detection. So for example, we have these diamonds, right? We put these in last time. And I remember we were talking about, if the character kind of jumps into these diamonds, we want them to, add a point to their score, make them disappear. Well, this is a problem of collision detection. We have to look at how the character, or we have to detect when the character is touching this diamond. And when they touch that diamond, we can add one to the score. So that is what collision detection is. We also have, for example, if we have the character here, we want them to kind of, we don't want them to just fall through the floor. We want them to kind of sit here, like stand on this platform here. Well, again, that's collision detection, because we have to detect when they're hitting the floor. That's all collision detection is. I think when you describe collision detection, it just sounds like okay, yeah, I understand what collision detection is, but why is it useful? Well, we use it for quite a lot of things. If you're shooting a gun in a game, for example, and the bullet is hitting something else, that is collision detection, because you're trying to detect when the bullet is hitting something else.
It's used in like everything. Like as Ben said, like you want to stop yourself from walking through a wall. You want to walk on the ground. You want to add points when you hit something, or die when something hits you.
Yeah, and it's used surprisingly quite a lot in pretty much every even the earliest games. So, for example, Pong, right? Detecting when that ball hits the paddle is collision detection. So even in the earliest video games, collision detection has always been a part of it. Because the idea behind collision detection is you want to be able to react and interact with the environment. It wouldn't be much of a game if we had a character that jumped around and moved brilliant. Yeah, but when they hit this diamond, nothing happens. That would be a terrible game. So we want to be able to do things like when they hit something in the environment, we can trigger some code, and that's essentially what collision detection is. So that's what collision detection is. I suppose the next question is, what is a collider? Well, colliders basically enable collision detection. So if we look at this diamond here, there is no collider on this thing. Colliders, it's a bit tricky to explain kind of what they are.
I don't know whether you would say like a collider is kind of like the outline of a game object, kind of like it determines a shape around it so that it can, for the collision detection to work, it's like an invisible barrier around the game object.
Yeah, that's a good way of explaining it, really, because essentially what a collider is you're kind of defining, hey, look, this is the area in which if something comes within that box or that circle or whatever it is, that is essentially colliding, if that makes sense. So it'll probably make more sense if I do this, because it'll give you a visual representation of it. So if you click on an object that you want to modify, I'm going to open up the prefab like we talked about last time. So I'm going to open up this prefab.
Edit all of them.
Yeah, exactly. So now we're editing all the diamonds, right? So if I click on add component, I'm going to add a component to all of these. There should be a menu here somewhere. Physics 2D. So we have 2D objects, so we need to go to physics 2D. This is kind of where it gets confusing, because there's physics and you've got all this kind of stuff. You've got, box collider, capsule collider, all this kind of stuff. But there is also a physics 2D menu, right? And it has all the same things, but for 2D things.
So is the physics menu for like 3D collider stuff?
Yeah. So the physics menu is all 3D stuff, right?
Right.
Now, if we put a 3D box collider on this 2D object, to be honest, I'm not actually sure what would happen. It would probably work, but
it might throw some errors.
Yeah,
possibly.
So the whole reason we have this physics 2D menu is for 2D objects, and also collision detection in Unity is classed as physics, right? I suppose it is a matter of physics.
Yeah, because walking through a wall doesn't really obey any kind of.
Yeah, well, I mean, part of any physics simulation is collision detection, and also collision response. If two balls hit each other, you want to kind of look at the coefficients of restitution and all that kind of stuff. So this 2D menu is all for 2D things, and that's great because we're making a 2D game, right? So there are tons of different colliders out there. So there's many different shapes. There's box colliders, circle colliders, I think there's polygon colliders.
Polygon, yeah.
Yeah, there's all kinds of different edge colliders, which is quite an interesting one as well. But I'll just show you, for example, a box collider. So a box collider, I don't know if you can see that actually, but let's go back out of this prefab. If I click on this, you can see the kind of, actually, I'm not sure what color that is. Is that yellow or green?
Green. Oh, I just
green.
really moved really close to the camera because I was trying to see what color that was.
So this green outline is kind of saying, if anything is within this box, I want to be able to detect collisions. So we can actually change the size of this box and where it is. So there's a little button here called Edit Collider, and as it says here, you can hold Alt to pin center in place and all this kind of stuff. But if we click on this little button here, it allows us to drag this box around. So we could make the collider smaller, for example, if we want them to only touch the innermost part of this diamond. So only when they hit this little box here, that they'll get it will collide, or it will detect collisions. Hopefully this makes sense. And you can kind of see it there.
I was like trying to see it.
Kind of see it, yeah. But if we drag this out, actually, let's do that. Also, by the way, if you want to edit it manually, there are two settings here. So there's the size, so you can make it very big, for example. So if anything, if the character comes within any region of this box, right? If the character comes into this box, it will go, oh, right, you're colliding with the diamond. That wouldn't look very good, obviously, because the character, just to give you an example. Yeah, just give you an example.
Yeah.
Say this little circle was the character, right? And they're going, oh, I don't know, walking along here, and then they jump, right? At this point, this would say that this circle, this character, is colliding.
They've collected it and they've collided with that kind of collider.
So as soon as they hit, like here, we can see that this circle is within this box. This box here is the collider for this diamond. So at this point, it would say, "Oh, you've collected a diamond," and that, So it's an interesting one. There are also other settings, which I'm not going to cover all of these settings, but there is, for example, a trigger. So whether the collider behaves as a trigger. So it's a bit tricky to get your head around. It took me a while to get my head around this as well. So a standard collider, right? If the character jump, that's not a word. Jump. if the character jumped into this box, right? They would with a normal collider, it would almost be like they are hitting a wall here, right?
It's like a barrier.
Yeah, like a physical barrier. So when the character jumps into this, it would be like an actual wall, which makes sense. That's what a collider is, right? If you turn on trigger, they basically they won't hit a wall, but it will still trigger when they
it comes like an invisible kind of. Yeah, it's like it just checks. It just checks whether is something triggering, is something within that like collider box.
Yeah. So if you don't have trigger enabled, this box will, when you hit this box, you'll kind of bounce off it, I suppose. That's maybe a better way.
It becomes solid.
It becomes solid, exactly. But when we turn this trigger on, we won't hit a wall, if that makes sense. So in our case, and I mean, we're not going to cover collecting diamonds in this episode, but when we come to actually do that, we will probably use a trigger, because when you jump into a diamond, you don't want to bounce off it. That doesn't make sense. You just kind of want to pick it up and then keep on going. So I just wanted to tell you what that is.
Trigger acts as like a sensor.
Yeah. So a trigger is almost just like a sensor. If you're within that box, within that circle, whatever it is, it will say, "Oh, you've entered the." It is like a sensor. It's like a proximity sensor almost. In fact,
I think that's a good way to explain it.
Yeah. Whereas if we had trigger off, it would be like an actual wall.
Well, yeah.
This will probably become more apparent when we get into actual using and working with collision detection. But I just wanted to note that. But yeah, at the heart of collision detection, it's all proximity sensing. So, for example, a box, you're just detecting the distance from the player to a box. Same with the circle, it's essentially a radius check. Even things like polygons or what's the word, like convex mesh colliders. Essentially, it's doing the same thing, but for every edge.
Yeah, the like mesh and polygon colliders are very kind of intensive. For like, it depends on what you want your game to do. If you want just like a box where they're just like the whole thing just is in a box and it's fine. But if you want more detailed kind of colliders, or like your I guess a good one would be, what's the name of the game where you put blocks and you make a line?
You put blocks and make a line.
You have like the L block and you try
Tetris.
Tetris. They probably will have like more accurate colliders so that it can fit into one another.
Yeah, so I think so. I've just shown you at the moment. I've showed you a box collider, so I'm going to just undo this. I'm just pressing Control Z here, by the way, just to undo my changes. So I'm going all the way back to what we started with, which is all of these now have a box collider, right? So what if I took off this box collider and I added a circle collider? So now we've got a circle. So if anything comes within this circle, it's going to be it's going to say, oh, you've collided, so that's great, right? Because we can make this circle bigger, we can, just like we did with the box, but as Danny says, right, it really depends on what the object is. So for us, a circle might work quite well for diamonds. Circle might not work very well for a character, if we have like Danny says, Tetris blocks, we don't want to use something like a circle, because that would be
it wouldn't fit the actual shape.
Yeah, it'd be horrendous. And this is kind of why there's different bounding volumes. There's different circle colliders and box colliders and all this kind of stuff. There is also let me show you the actually, let's go back to the prefab view. Let me turn this off. Yes, there we go. So if I go here, I'll remove this one. There is also, I think, the polygon collider 2D. So this as you can see is a bit different. This allows you to it's kind of made a rough shape of what this is, and you can actually modify this so you can move these points in. So you can say, actually I want the shape to kind of look like this. So this is the most accurate of the colliders. You can actually physically drag these points and make a collider of any shape that you like. But as Danny rightfully says, this is much more intensive than something like a box collider or a circle collider. I'm not going to get into too much detail of why that is, but essentially with a circle collider, it's a proximity check. You're just checking, is this thing within the distance of this thing? Yes, it is. Brilliant. But with this, imagine we had, there's only a few points here, but say we had hundreds of points, hundreds of vertices in this polygon. We would have to check for each one of these. We'd have to look at each edge and then compute the a projected vector to the center. You'd have to use the dot product to compute the, what's it called, the separating axis thingamajig for object-oriented bounding boxes. And then, it's a massive calculation. So just be aware, don't put a polygon collider on everything, because your game will run pretty slow. But sometimes sometimes this is needed. Sometimes you have a very strange shape like this that you want to detect. But most of the time we can kind of just go with a rough shape like a circle or square. But we've talked quite a lot here about polygon colliders and all kinds of different colliders. But I just wanted to make sure that you understand that, because that's a big part of what we're going to do today, but also a big part of what we're going to do later. And one of these things, one type of collider is something called a tile map collider. So you might be thinking in the back of your head, okay, well, how do we actually make this environment like how do we make the floor solid? How do we make these walls solid as well? Well, that's kind of the job of tile map colliders. So it's quite easy to add a tile map collider. In fact, I've already added one. Silly me. So so all you do is you click on your tile map, this one, for example. Maybe let's give this a different name. Let's call it something like walls and floor or something.
Back to naming conventions.
Yeah, in traditional bad naming convention style, let's go with walls and floor. So at the moment, and again, just to give you a bit of an idea of what is going on here. So let's just quickly move this circle here. So imagine this is the character, right? And I'm going to put a collider on here. So I'm going to put a circle collider. So now this has an actual collider on it. Now we're going to cover this later on, but for now, just don't worry about it. I'm just going to add a rigid body, and again, I'm going to kind of show you what this is later. But when I click play, you'll notice that this character here just falls right through the floor.
Oh no!
Right. So
circle.
Yeah. So imagine if this was the player. I mean, it's not a very good game because, well, the circle is all the way down
just
here, and that's
continuously falling.
That's not good, right? So our circle, our character is literally just falling through the floor, even though they have a collider, right? The character is just falling through the floor, as you can see. So the first question is, why is that happening? Well, this character has a collider on it, right? But the environment itself doesn't have a collider on it. So how do we actually make these walls and the floor and everything? How do we make that solid? Well, we just go to add component, and luckily for us, there is something called it's not in here, but if you just type in tile map, it should pop up with a tile map collider 2D. So we press that, and as you can see, we've got loads of little green boxes here, but not in this part here. So this part here, as you can see, is like I think they're gray lines. I might be wrong.
Yeah.
But yeah, these kind of gray lines here, this means that there's no collider here. But these tiles are marked as solid, and that's what these green lines are signifying. So let's try that again and see what happens. Now our circle is flat on the floor. We could move this circle up, right? And it reacts to the environment. I can throw this around, and it's solid, right? And that's what a tile map collider does. Is it makes these walls, it makes these floors actually solid. So that's what that is. And again, don't worry about rigid body 2D. We're going to get onto that in a second, so don't worry about that. But I just wanted to give you an idea of what's going on here. So yeah, that's what you need to do, is just add a tile map collider to your tile map. I think we have enough time to talk about layered tile maps as well. So one thing that you might have thought throughout this is, oh, okay, we have this kind of environment, but if you look in the game, we just have like a blue background. Yeah, and sure, yeah, we could change this to black or whatever, but wouldn't it be nice if we had some nice tiles in the background to match with the game? Well, how do you do that? Well, okay, so you could, for example, open up the tile map window again, which is somewhere. I always forget where it is. It's like, what is it? 2D tile palette. So we could click on this and draw tiles like this. That's great, but you might have noticed that, look at this, all these tiles are green, right? So we don't want this. We don't want these to be solid. So because if they were solid, then
you would collide with them. Like you wouldn't be able to go through that area.
You wouldn't be able to move because all of this here is solid, right? That doesn't make sense. So how do we get around this? How do we have tiles in the background which are not solid, and then these tiles, which are the walls and floors, how do we make those solid? Well, we've already got one part of it down, we've got solid walls on the floor, right? That's great. What we need to do, okay, is we need to make another tile map, right, that kind of sits behind this. So we can call this maybe walls and floors. Again, it's probably a bad name. Let's call this the foreground, okay, the foreground elements. And also, by the way, you find this in pretty much any 2D game. You have different layers. I think Danny was mentioning, even in the first episode, that we have like different kinds of 2D games. And we have some things in the background, and we have some things in the foreground. We have different layers of things. Even some of the oldest games, like again, Super Mario World, have those kind of layers, even built into.
You can see like the castle in the background. That's what I could think of in the Mario games.
No, it's true, right? You have different layers of things, right? So what we're going to do is we're going to make another layer, right? Another layer that sits behind this foreground. So I'm going to save myself some time, and I'm just going to right click and click duplicate, and I'm just going to call this background, right? What we need to do is remove this tile map collider, because otherwise we'd run into the same problem. I'm just going to remove this. Okay, so the background itself, as you can see, the foreground and the background are two separate layers. So if I click on the foreground, you get all these green lines that are saying this is all solid. If I click on the background, it's not solid. I don't get any green lines because I've removed the tile map collider. So I can paint into this here, as you can see. So I'm just painting these tiles here, and I'll probably make this a bit bigger. Actually, it's quite small. I could, for example, make this a little bit bigger. So let's zoom in, and also I think you can select. Oh, that's horrible. Don't do that. I'm just gonna, to save time, I'm just gonna grab all of this and just paint all of it here. There we go. Brilliant. So now we have a background. If right, you might be painting yours, and you might see something like this. You might have these tiles that are kind of above the foreground, right? If this is the case, and you want the background to sit behind the foreground, come over here to the tile map renderer and look at this number here, which is the order in layer number, right? If you've ever done any web development, this is like the Z index. So what this is it's kind of the order of this thing, right? So in the foreground, the order of this is 0, right? So if we set this to something above 0, it's going to sit in front. If we do -1, for example, it's going to sit behind. If we put it at 0, it looks the same. 1. So basically, yeah, this number here controls the order of this layer. So as you can see, values lower than 0 are going to be behind the foreground, because this number is at 0, whereas this one is -1, so it sits behind it.
It's like in PowerPoint when you're trying to like put an image behind some text. Basically, it's just layers of elements.
Yeah, that's a really good example. So when you open up PowerPoint or Word or whatever, and you've got something sitting behind something else, that's kind of what that number controls. -1 is kind of at the back, and 0 is at the front. -2 would be behind -1 and 0. So that's all this does. It just controls the order. But now look, we have a game with some tiles in the background. Yippee! That looks. I mean, it's a bit zoomed in there, but it looks good to me. So that's how we can do layers of tile maps. So yeah, that's. I just wanted to talk about colliders just for that reason. So now we have an environment that is actually, it's solid. We can actually start doing stuff with it. So I suppose the next thing I want to talk about is input, right? So we mentioned we'd talk about input. So why am I talking about input here? Well, as I said, we're going to look at how to move the character around the environment, and a big part of that is detecting, if you've pressed the space bar, make the character jump. If you've pressed the left and right arrow keys, make the character move left and right. That's what we need to do first, is kind of just detect when you've pressed a button on the keyboard and stuff. So I'll get onto that. So I'm going to enter my scripts folder as we did before. I'm just going to right click and create another script. I will call this character movement, I guess. That's not a bad name.
That isn't actually a bad name.
Yeah, it's a pretty good name. I'm proud of myself.
Well done, Ben.
Yeah. And I suppose actually the first part I've completely forgotten about here is to actually put the character in the game. I mean,
right. Yeah.
So let's get onto that. So I'm going to go to the sprites folder. There are all kinds of sprites here, and I suppose we should either go with the human or the pig. I'm going to go with the pig because why not? And as we did before, there are a bunch of different sprites here. And for now, we're not going to touch animation. So I'm going to turn this, like we did before, I'm going to turn it onto sprite. I'm going to set this to 32. I'm going to turn off compression. I'm going to do point no filter. And yeah, as you can see, if I drag this in, actually that's working very well. Yeah, we've got a pig, right? But it's the whole thing. This is exactly what we were talking about before. This is an animation, and we want to grab one of these. Okay, there's just many of these, so we want to have one sprite, but we need to cut out all of these many sprites. So I'm going to do the exact same process we did before. So actually, that's my bad. I need to go here and set it to multiple because there's multiple things in this image. Click the sprite editor, and I'm going to slice this. So I'm going to go to cell size. In this case, as it says here, it's idle 34 by 28. So I'm going to put in 34 by 28 and click slice. And now, hey, look, we've got loads of little sprites that we can use for our character in our game. So let's click apply. And now we have the same thing. We can click this play button. We have all these different kind of sprites. So I can drag one of these, for example, this little thing here. And now look, we got a little character, that we can use in our game.
So cute.
Yeah, it's very cute. The guy who made this art pack, seriously, very
skilled,
very skilled, very impressive. Yeah. So we have a kind of sprite thing in our game. There are one thing that we'll come across is the sprite renderer, and we're going to work with this in a bit. But there is, as you can see, there are a bunch of properties, but one of these is sprite flipping. So if I click X, you can see it flips the sprite this way.
Just a little dance.
Yeah. And if I do Y, it goes that way. So it allows us to flip this. And why this will come in useful is if we're moving left, we can go this way like that. And then if we're moving right, we can flip it and move right like this. Because otherwise it would look strange if we were moving around like this. So yeah, that's our character. What I will do as well is I will make a character prefab, just because it makes sense. So let's call this character, and I'll drag this in here. So now we have a prefab for the character that we can modify, again, across levels and stuff like that. So we have a character prefab that we can use. What I'm going to do is actually get into actually moving the character around, right? So
I'm not sure whether you can hear that on my microphone, the banging.
Yeah, yeah, slightly.
Right,
yeah.
Okay. Sorry about that.
It's all good. So if I double click on the character movement script, so I'm just editing this script now. This is saying, do you want to recover this? No. So let's open up this in Visual Studio. Again, it takes quite a while to open. So we have a script here that has just a start function and an update function, just like we did before, right? Now what I'm going to do is I'm going to do just a little if statement here and do if something called input.getKeyDown, keycode dot space. I'm going to do debug.log. You have pressed space, because the easiest way to describe what this is doing is to actually show you. So what this is saying is input.getKeyDown. So if I hover over this, it says returns true during the frame the user starts pressing down the key identified by the key code enum parameter. So basically, if they have pressed this key, which is space, the space bar, but there's loads of keys, right? There's the A key, there's E, end, equals, all of these different keys. If you press the space bar, it's just going to say in the console you have pressed space. So let me just play this for you, and I'm going to attach this script to the character. So I'm going to open the prefab like we did before, and I'm just going to drag on this this character movement script. So now this is affecting the character. If we go back and I click play for you, the character obviously isn't moving at all because it doesn't have a collider, it doesn't have a rigid body. But if I click into the game here and I press space, and I'll try press this loudly so you can hear me doing it. Let me. I've got my keyboard. Here we go. As you can see, it's saying you have pressed space. So every time I press space, we should. Oh, hang on. We should get a new message. So that's all that's doing, is it's just detecting when I've pressed the space bar. That's great, because now instead of just saying you have pressed space, we can actually move the character. So we want to change this to, move the character. That's all this is doing. But that's what this input.getKeyDown does. Is it just detects when you've pressed a key down, right? So yeah, there are other ways of looking at input. So there's not only get key down, there's key up. So when you've released a key, there's all different kinds. There's get key, and what get key is it detects when you've held a button down. So I'll show you this one, because we'll use this in a bit. But let's say you are holding spacebar down, right? so let's go here. I'm going to clear this console, and I'm going to press play. So if I press and hold this down, again, I'll try to do this on camera so you can see. Ignore my keyboard. Here we go. So if I press and hold it down, and then I release, yeah, you can see that it's saying something when I'm pressing and holding this down. So that's quite useful, because that's what we want to do for the left and right arrow keys. But for space, for example, when we press the jump button, we would just want the character to move up. So that's what we're going to do. And yeah, there's other kinds of input as well. So there's not only get key down and all this kind of stuff. What's quite useful about Visual Studio is you can just press dot, and it should pop up with a bunch of things you can do. So there's get key down, get key, get button. So that's for gamepads. Get button down, any key, which is, I assume, yeah, if any key or mouse button is currently held down. There's things like the device orientation. So if you're working on mobile, you can do things like detect if the device orientation has changed and stuff. There's get axis, which is quite useful. We're not going to use it, but that is quite useful. There's all different kinds of stuff here. There's get mouse button, right? Get mouse button down, get mouse button up. So if you wanted to work with clicking something, all kinds of different stuff in here. But what we're going to use is get key down, and inside this you can put in any key you like. So there's key code dot, and like I said, look, there's all different kinds of things. So I could press the M key to jump for some reason. I don't know why you'd want to press the M key to jump. So
yeah, that seems like such a backwards thing.
Yeah.
After years of playing games, it's just like spacebar or like
yeah. So that's what we're going to do, is we're going to use this. So in here, we want to do something like make the character jump, right? That's what we want to do. So I'm just going to leave that there. The next thing we need to do is, as I pointed out, if I press play, the character will just stay here, right? The character is just staying here. So we want to make this character react just like we did with the circle. Do you remember I showed you the circle that dropped down? And this is kind of where we get into the bit about physics. Okay, so let's talk about physics. So I'm going to put a collider onto this character. So there are different kinds of colliders. We could use a circle, we could use a box. But the one that you often find on characters is a capsule collider. And this one's so small that it basically is a circle. But I can
so cute.
yeah, but I can move this collider to roughly the boundaries of this character. So I'm just making this collider the same kind of size as this character. So I'm gonna. It's kind of like a circle. It's a bit like an oblong. It's not exactly an ellipse. It's kind of like a rounded rectangle or something. But
I think this series is just us like naming shapes. It's literally what this is like.
I mean,
intended to.
A common theme throughout this series is badly naming things, specifically shapes, right?
Yeah.
But yeah, you can drag this capsule out to be quite tall. I'm going to do it to about here. So this collider is going to be the size of this character. And, you can make this even smaller if you like. You could make it quite thin like this, but I'm going to make it about this size here. So now that the character has a little capsule collider that we can use, I'm going to exit out prefab view. And yeah, now we have a collider. But again, if I press play here, nothing is going to happen. This character is not going to fall onto the floor, right? Nothing is happening. So how do we make it actually interact with the physics? Well, as you saw before, this is what rigid body is. So if we put on a 2D rigid body, all the rigid body really does is it allows us to make objects interact with the physics system in the game. So if I add a rigid body, as you can see now, the character is sat here, and if I move this character, if I click on this character and move the character up, you can see that this character is kind of dropping
has like
down.
gravity.
Now has gravity, yeah. So this is now a physics object. We can now apply physics. Now, as you can see,
oh no,
the character is rolling around. This isn't good. We don't want our game to have a character where we accidentally tip the character over, and I mean, we don't want that kind of behavior. We don't want the character to be able to do this, for example. We want the character to. We don't want the.
So cute.
Yeah. So that's all a rigid body does. It allows the object to kind of interact with gravity. It allows it to kind of fall onto the to hit walls and that kind of stuff. It basically turns it into a physics object. And there's all different kinds of settings here. If these are quite confusing, don't worry about it. Some of them, even now, like I've been doing Unity for years, and some of this is just like, what? we have, for example, kinematic rigid bodies, and I'm not going to touch those today. But we can set the mass of this object. We can make it quite heavy. We can give it more drag. We can turn up the gravity for this object. There's also different types of collision detection. There's discrete and continuous. I'm not going to get into that, but that is quite an important setting. And there's other stuff here. So the question I kind of pose to you is how do we solve this issue of we have a character, and sure, yeah, it's dropping onto the floor. Ignore this error. If we do this, we don't want the character to topple over like that. So how do we do that? How do we sort that out? Well, that's a good question. Well, yeah. So there's a little flyout here called constraint. So if we press this, you can see that there's one here called freeze rotation, right? And that is exactly what this does. So if I tick on freeze rotation Z and I click play, now the character will not rotate. It will always stay upright. So if I try topple it, as you can see, the character will never tip over. It will never, topple over and do a flip, for example. It might fall off. It might fall off an edge, for example, and hit just so slightly, just so that it like hits it or something. But it will never topple over. It will always stay upright, which is perfect for what we want.
Yeah, it makes the character look. Well, it just acts a bit more natural. They're just obeying like what we would think like a normal person would just, well, I wouldn't say you would fall exactly straight down, but for like a character in a game, you don't want them to continuously spinning, because then they're never upright. They might not go back to their original kind of upright position.
Yeah, usually in 2D kind of pixelated games, a lot of the, if you want to do flips and stuff, it's covered with animation. There are, for example, sometimes where we want to actually put objects in the environment that do tip and topple around and stuff. So, for example, if I wanted to make like a little box or something that topples around, I could do the same. You know, I've got a little square here. I could make this look like a box, right? And I could turn on a box collider 2D for this, and a rigid body 2D for this, and yeah, now we have like a little box that might tip around, and that's perfect for a box or something. But for the character in this case, we want the characters to stay upright. Yeah, and I realize, you know, we've gone through this in quite a lot of detail, and I think we might run over, but I think specifically in this case, learning about rigid bodies and collision detection and how to move stuff around the environment is quite important. So we're going to intentionally go into this in a bit more detail. Right. Okay. So we've talked about rigid bodies, we've talked about physics, we've talked about collision detection, we've talked about all different kinds of stuff, but we haven't covered the one thing that this lesson is about, which is moving the character, actually moving this character around. So far, we've just said you are holding the spacebar down, but we need to make the character jump. So how do we do this? Well, the next thing we need to talk about is different movement types. So when you move a character in a game, usually there's different ways of doing it, right? So you can go down there's two main ways of doing it. There's what I like to call translation-based, and there is something called force-based, right? So translation-based is kind of, you can imagine this as like physically moving character pixel by pixel, right? So you're saying, hey, I want this character to actually move in the environment. So I want to move it, 5 pixels to the right, and then I want to move it 5 pixels up. That's what translation kind of based movement is. So usually how you do this is we've already done this with transform.translate. Actually, we did transform.position equals. Do you remember in the diamonds thing, we were doing transform.position equals?
We were moving the diamond up and down, up and down.
So that was kind of translation based, because we were saying we want to directly alter the position of this diamond up and down, right? So we were actually concerned with quite literally changing the position.
Yeah, we just wanted it to go like 1 pixel up or 1 pixel down. Like we only wanted it to do that. It was very specific in what we were requiring the diamond to do, if that makes sense.
Exactly. So usually you find this kind of stuff. You find transform.position equals. That is kind of translation based. You also might see this here, transform.translate, which is essentially the same thing. But essentially what you're doing in translation based movement is you're directly manipulating the position of something. So you're saying, like Danny said, with the diamond, move like 10 pixels up and then move 10 pixels down. So that's what translation based is. And you, for example, what you could do is when you press space, you could say, okay, well, move the character up 10 pixels or something, and do that quite smoothly. So that's one way of moving the character around. It's not the best way.
It's really reactive to the environment as well.
Yeah. So the issue with this kind of approach, as Danny rightfully says, is that there's no regard to collision detection and the environment. So if, for example, you are under a platform and you want to jump using translation-based kind of movement, because you're saying move 10 pixels up, right? The Unity doesn't really care about physics. It's just like, I'll move them 10 pixels up, whether that's...
I've been told to do that. I don't care about your colliders. I need to move 10 spaces up.
Exactly. And I mean, this is kind of the annoying thing about computers is they're very, very literal. When you say I want to move 10 pixels up, it will do it. It will go. You've told me to move 10 pixels up, so I'm just going to disregard physics. I'm just going to go.
Physics?
Yeah. So this is quite tricky because we might go through walls and all this kind of stuff. But this is one way to do it. You find it in things like quite simple games. You can use translation-based movement. So how do we get around that? Well, this is the other approach, force-based, right? So instead of physically moving the character pixel by pixel, you're applying forces to the character or to the sprite, which allows for reacting with the environment. So instead of saying, hey, I want to move this character 10 pixels up, you're saying, oh, I want to apply a force to this object so it will move up. So usually with this, you'll have something like what's this thing? Something like rigid body dot add force, and that's usually there are other ones. There are things like rigid body dot add torque, I think. Even things like the rigid body dot velocity equals where you're directly setting the velocity of something. All of these are force based, right? So instead of saying physically move the character 10 pixels up, we're saying I want to apply a force to move the character up. And there's a very slight difference there. The good thing about force based is it reacts well with the environment. Okay, so there are, for example, if we make the character jump and they're under a platform, because we're not directly manipulating the position, we can say to Unity, apply a force, and it will hit the platform, which is what we expect, right? We want it to bounce off.
It's basically like the character is like your little puppet. You're pulling a string, like you're pulling them up, or you're pulling them to the right. You're pushing. You're adding that kind of force, to that character rather than say, we want you to move 10 pixels. You're just saying, I'm going to push you that way out of the force of this.
Exactly. I mean, thinking about it that way, like pushing something, is a good idea. So with translation based, it's like you're physically setting the position, right, in translation. With force based, it is like, you've got a little stick and you're kind of pushing it along. I like to think of jumping in games with force based movement as like gusts of wind. When you press space, you're kind of you're doing
it's like a little explosion. Like it's just it's a force driving it up or driving it forward or backwards.
So we're saying gust of wind, move the character up. The benefit to force-based stuff is that it reacts with the environment. You have a platform, the character's going to hit it and bounce off, which is what you'd expect in a game, right? So there are different ways of doing this, but I wanted to cover these two because these are the two most important. Now, the question is, which one are we going to use? Well, we're not going to use this one, so I'm just going to delete this, right? So we're going to do force-based movement, and I'm just going to show you how to actually move this character around. So what we need to do is move when we want the character to jump. We want to apply a force upwards, right? Because that makes sense. We want to kind of have a gust of wind that pushes them upwards. So let's do that, and I'm going to write out the code, and then I will show you what all of this means. So I'm going to make a rigid body and do get component rigid body 2D, I should say. Yeah. So let's put this here. Rigid body 2D. So what is this doing? Well, the most important part of this is get component. So let's try hover over this. Oh, it doesn't give us an explanation. Great. So what get component does is it does exactly what it says. It gets a component on this object. Again, this is why we wanted to talk about components so much in the previous episodes, is that because of this function. So right now, I mean, this is going to compile and stuff, but right now on our character, we have many components. We have a rigid body 2D, we have a capsule collider 2D, we have character movement, we have a sprite renderer, we have all these different components attached to this object, right? And one of them is the character movement script. But in the character movement script, we want to have access to this component here, if that makes sense. So we are in this script, this is what this editor is, where we are editing that script which is attached to this object, and we want to access this rigid body because this is how we're going to add force. We're going to use this rigid body to actually add a force to this character. So that's what we're going to do. We're going to access this rigid body from here. How do we do that? That's what get component is. So get component rigid body 2D is going to get the rigid body on this object. So this is going to get the rigid body and store it into a variable. And now we can do rigid body dot, and there's loads of different stuff here. So we can do things like set the gravity scale from here if we want. We can do all kinds of stuff, but one of them is add force. And as you can see, there's many of these. There's add force. There's add force at position for things like explosions. Relative force, add torque. The one we're going to use is add force, right? So let's have a look at this. There are two different versions of this. We're going to use the second version. So the first force is the actual force that we're like the direction of the force, right? It's a vector because it's like an arrow, it's an arrow upwards, it's an arrow downwards. In this case, we want an arrow upwards. So we're going to do vector 2 dot up, which is up direction. And then this part here is the force mode. Now, force modes are they're a bit tricky to kind of get your head around.
Yeah. So are there different kinds of like force modes? Are there? Well, I do remember there's like ones where there's like impulse and there's for actual like force mode of force, and they do different things, don't they? Like the impulse kind of is that jump upwards, and the force one is like just pushing, and it's that constant force forward.
So the idea behind force mode is there's different ways of applying a force. So we have force and impulse in this case. I think for the 3D, there's other ones like explosive force and acceleration forces and this kind of stuff. But in 2D, we have two types of forces. So we have impulse and force. Now, this kind of makes sense because there's different kind of forces in real life that we can kind of relate this to. So an impulse is like an explosion. It's like a sudden force, it's like a gust of wind. It's something that comes from nowhere and is a very, well, it's like an impulse. It's a very quick...
it's basically like you're jumping. You're just applying like a quick upwards force, and then you're falling back down again.
Yeah, exactly. A force mode 2D dot force. I mean, the naming convention is really dumb, right? But,
even worse. I guess you can see where like computer scientists get their like naming convention. we're just not good at naming things.
Yeah. So this force mode 2D dot force is like a kind of like an acceleration force. It's almost like when you're bump starting a car and you're behind the car pushing the car, right? It's not an impulsive force. It's because if it wasn't
applying that pressure forward. Well, you're just applying that constant pressure of
you're pushing a car and the car slowly speeds up, right? It's not an impulsive force because otherwise, you'd start pushing your car and the car would fly off because it's like it doesn't make sense, right?
No.
And that's kind of the difference. An impulsive force is like a quick, sharp force, like a gust of wind or an explosion, right? Whereas a force mode 2D dot force is like a, like I said, you're pushing a car or something. It's like a constant
gradual
force.
Like push. Yeah, you're getting up to speed in a way.
Yeah, exactly. So in this case, we do want the impulsive force because we want to jump. It's like a sudden gust of wind upwards, whoosh, and then it'll go upwards. So, apply the gust of wind upwards, right? So what I'm going to do is I'm going to run this, and let's just have a look and see what happens. I don't think much will happen, but we'll see. Let's click play, and I'm going to press space here. As you can see, the character is moving, right? It's a very small,
tiny little hop.
The tiniest little hop, right? So how can we make that a bigger hop? Well, quite easy. We just make this upwards. So this vector 2.up is the direction, but we can actually scale this by doing, something like jump speed, and we can put a, back to public variables. Remember we talked about it last time, where we can set things in the inspector. We're going to do exactly that. So we'll do something like jump speed. Let's just make this. What is that? Oh, right. This is. Sorry. I am being dumb. I'm really being dumb. Okay. I thought this was the yeah.
I got confused for a second. I was like,
yeah,
got that error.
That's my bad. That's Even after all these years, I think, I'll put a public variable in a function, and that'll work.
It not working?
So now we have a jump speed that is that can be used here. So if we go to the editor, as you can see over here, it should pop up with a jump speed. So we can set this to whatever we like. We can set this to 1, for example, for very, very short hops, but we can turn this to 5, for example, and get a bigger jump like that. So it's like a sudden gust of wind upwards. And also, I'll probably set it to about 3. I think that's about right. Yeah, about 3, I think. So, yeah, we have a little jumping character. One thing you might notice, though, is I can just jump continuously. I could constantly jump upwards, right? I could keep jumping like this. And as you can see, it's actually reacting with the environment. It's hitting this wall and coming back down. So this isn't much of a jump, right?
It's more flying.
Yeah, because we only really want to be able to jump when we're on the ground. Now, in the interest of time, we're not going to cover that today, but later on, we're going to polish this and make it a lot better. We're going to have a look at actually improving this character movement. But at the moment, we're just going to leave it like that because it's easy to
flying
understand.
Pigs do fly, Ben. Pigs do fly.
Yeah, exactly. That's what we should call the game, right? The flying pig game.
Oh my gosh!
Yeah, instead of just a 2D game. So yeah, now we have a pig that's flying, right, and it's reacting with the environment. That's brilliant. Okay, so we've kind of got the jump sorted. Like I said, we can sort the kind of stuff where we can only jump on the ground at a later point. But for now, just want to touch on that. There are other ways as well. Like we could have done this another way. The next thing we need to do is look at how we're going to make the character move left and right. And it's actually very similar to what we've just done. We've applied an upwards force to jump. How do we make them move left or right? Well, you guessed it. We just apply a force left and right. Okay, so what I'm going to do is essentially the same thing, but with different keys. So if input.get, I'm going to use get key in this case. Okay, so I'll talk about that in a second. But I think it's left arrow, or for example, if you wanted to use ASD, you could use A. But I'm going to use left arrow. So what is get key? Get key is like get key down. Now get key down only fires when you press the key down. It go because it only does it once. What get key does, and I showed this, is it will always trigger true whenever you're holding the left button down, because we don't want to. We want that. We want to be able to hold the left arrow down, and then when we release, the character stops moving. We don't want to, constantly tap like
go
that.
Go right. Yeah. Oh, go left.
So this makes sense. Like when the player has held the left arrow down, and we can move the character. So how do we move the character? Well, we can make another variable, maybe call it move left right speed or something. I don't know. Probably better if I do move X speed, because it's I'll leave it with left right speed. Let's go with that. So we're going to take this line essentially and do the same thing. Now we could do force mode.impulse, but I'm going to use force because like I said, there's different kinds of ways of applying force, but when we're doing left and right movement, we want to be able to, it's kind of like pushing a car, we don't want to.
Well, it's not an impulse. You're not impulsively moving forward. You're just like gradually having that movement or like that continuous force.
Yeah.
Left to right.
Exactly, right. So we're going to apply a kind of pushing force, not an impulse force, because otherwise the character would just fly off the screen, and we don't want that. So let's change this jump speed to left-right speed, right? So now we have this is vector 2.up. We want to change this to a left kind of force, right? So vector 2.left is an arrow pointing that way, whereas vector 2.up is an arrow pointing that way. But actually, I think my camera's flipped. That's right on your screen, but
yeah,
that way.
Oh wait, no, that way.
I don't know why I did this when I have a left arm. That's silly. But yeah, okay. So let's try this. So we're just doing, if they've held the left arrow key down, just apply a left kind of force, a force that's left with this speed, and it's a pushing force, right? So that's all we're doing here. Let's move over here and try do this. So we should have another variable pop up here, move left right speed. Let's go with, I don't know, 2 for now, and let's see how fast that is. And we will. So our jump speed is again very small, but we can change that to, I don't know, 3. So we have a jump, and yeah, the character character isn't moving. I think we have to turn this up to like 10 or something. Yeah. So now you can see.
For a second, I was like, "Oh no, did the code just like break already?"
No, I had a panic. I was like, "Oh God, I don't know what I'm doing." No, no, we're good. So yeah. Now I can't move back right, but I can move the character back here. But as you can see, when I press and hold the left key down, we've got a character kind of moving. You might also notice as well with this, the character can be in the air, and I can still move them. But again, we can sort that out at a later date. Now I'm just going to, because I've realized I've actually haven't been modifying the prefab, so I'm just going to turn this to 3, and let's go with 10. I'm going to go back to the character. So let's do exactly the same thing, but for the right direction. Now this is very easy because it's the same thing.
Just going to the right.
To the right. So turn this to right, and I'll do this to right as well. So when they hold the right arrow key down, do the same thing, but right, and we should have a little character moving around in our game. So I'm just going to zoom out here so you can see a bit. And yeah, let's have a look. Oh, okay. We have errors. Oh, I think I've accidentally removed the. Have I got this right? Yeah, I think I've removed for some reason the rigid body. That's my. Just ignore me. That's fine. So it now has a rigid body. It has all this. I don't know why or how I removed that, but there you go.
Didn't see you removing that, but
oh, that's not good. Do you know why this is? This is because we haven't frozen the Z rotation. So now we have a character that is kind of rolling around. It's not a very good game. I mean,
that looks so amusing though.
I mean, this might be a game that you'd like. You just have a kind of pig rolling around. But so to fix that, let's go back.
It shows the importance of having that freeze rotation.
Yeah. So I'm going to turn that on and go back. I think I know why that happened. It's because I added the rigid body when I wasn't in prefab view. So I'm going to save that and just make sure that's all good. Now we have the frozen Z rotation. Yeah, now we should have a little character that moves around kind of as we expect. So it's not a very good jump speed, but we could jump around. But we have a little character moving, which is great. It's not like I said. It's not very good in terms of we can jump whenever we like and all that kind of stuff. But we will get onto that at a later point.
We've got the basics down.
Exactly. Yeah. I think one last thing in this script that I want to touch on is flipping the sprite. So you remember I talked about flipping the sprite. So we can do that by doing something like let's have a look. We can do something like this. So we can do get component. So we're getting the sprite renderer component this time. Okay, so we're getting the renderer on this object, and we can set flip X to false when they're moving left. So flip.
Yeah, because when the character starts off, they're looking left. So you
Yeah.
don't want to flip, or you don't need to flip it left. It's already there. So we don't want it, which it's false. And then when it's going right, we do want it to flip so it's true.
Yeah. So all this is doing, if that's a bit confusing, is so we are in this script, we're in character movement, and we're getting the sprite render component. That's what that get component does. And we're toggling this on and off. So when it's like this, it's true. When it's false, it's like that. Okay. So that's all we're doing. Okay. Pretty straightforward. But now there's a slight difference. You'll probably see the slight difference here. When we move right, the character is facing that way. And when we move left, we're moving left, the character's facing that way. When we're moving right, the character's facing that way. So that's just a little thing. We've got this character now moving around in our game, which is great. We can start actually building this into more of a game. But we have the first little bit of our game. If you want, for example, well, I suppose one thing that might also be of interest very, very quickly, because I do realize we are we're over time. Let's say, for example, you wanted the camera to follow the player around. So I'm going to kind of focus the camera here. Now you can write a script to make the camera follow the player, but one of the easiest ways is to actually just move this as a child of the character. So now if I move the character around, the camera follows the player. As you can see on the right there, I'm moving this character around and the camera is following. Okay, so that's all I've done is I've just dragged the camera from here. Let me do that again. I've dragged it from here and I've put it inside this character. So now this camera, getting my words mixed, this camera is a child of the character, so it's going to move wherever the character moves. So now if I click play and we look at the game view here on the right, it should work. Yeah, so we should have I can have this character moving around or whatever, and the camera is following the player around, which is great. That's kind of what we want in a game. So yeah, I just very quickly wanted to talk about that, but I think that I'm not sure what else we have to cover. I think
that'll be a good stopping point for today. So thank you everyone for attending this session or viewing this session when it's uploaded onto the YouTube. The sessions will now move to once a week on Wednesday at 4 p.m. We're unsure how long this series is going to go on for, but we want it to go on for as long as we explain the concepts to you, so it doesn't some sessions we might go over, some will be under. So yeah, we'll see you on Wednesdays at 4 p.m. for a weekly Ben and Danny show.
Yeah. And some of these we run over, like for example we run over today, and well, it wasn't yesterday,
Tuesday.
Sorry, but Tuesday. No concept of time.
I have no concept of time anymore.
But it's for example, the reason we did this time and last time is because these are some of the most important parts of the game, right? And sometimes we will go over and you probably think, geez, what a slog. but
that's a long episode.
Yeah, but these things are quite important. So and I think as well, the whole point of this series is it's a gentle introduction. So we're going in quite a lot of detail just to make that process a little bit easier for you. But yeah, I think that's pretty much it.
I think we'll say our goodbyes now. We'll see you at 4 p.m. on Wednesdays.
Yeah.
Goodbye, everyone.